class. So I know you guys are a little bit behind my first class, but not very much. Okay. So yeah, we'll finish 6-7, and then we'll cover 6-8, which if you understand 6-7, 6-8 is not that bad. Okay. Even though it's story problems, it seems like it would be more difficult, but as long as you understand how to throw things in the calculator is going to be a big thing today, making sure that you can get things in there as accurately as possible. So let's see what questions you guys may have from 6-6. And 6-7, I guess we really only covered up through the first 15. Yeah, so, but we'll cover more of it again.
81 on 6-6.
81, sure.
And 11,
Oh, yeah.
16.
Yeah, well, it says the little hint of multiply by dx.
And can you just set up 43? I just don't know what the first step is.
Okay. All right, let's take a look at those four then. So if you got your homework, you want to pull it out just to make sure you got it. If you haven't done it yet. Okay, so the hints that I gave you guys yesterday is combine your logs if you can, okay, if you have more than one on a side, okay. And if you have the same bases, which you do,
You drop them.
you can drop them,
But I wasn't sure what to do with the X and the 2.
the 1/2 and the 2, or the X and the 2.
Those, yeah, those X.
Okay, so what we need to do is we have to work with these. This is not log of something equals log of something because we have these numbers in front. So what we're going to need to do is somehow move those coefficients, basically is what they are. So how do I move the 1/2, or what could I do?
Put it to the power.
You can make it as an exponent. So we're going to rewrite this using our power rule. So log base 3 of x to the 1/2 equals log base 3 of 2 squared. Okay. So then you can actually, now that I have a log with the same bases on both sides, then those can drop out with our 1-to-1 rule. Okay. So then I just have x to the 1/2 equals 2 squared, which is 4. Okay. So how do I solve for x?
Square root.
Not square root, because it actually is a square root.
Here.
You'd square it. Okay, x to the 1/2 is the same as the square root of x equals 4. So it's not, the answer is not going to be 2, it's going to be 16. So you're going to take it to the power of 2, so that 1/2 times 2 is the power of 1. So that gives me x equals 16. And then you can check that if you wanted.
So you put it to the power of 2 because that is what would cancel out the 1/2.
Yes. Yeah, exactly. So I'd have 1/2 log base 3 of 16 equals 2 log base 3 squared. It's not an easy
Is that
one to
right?
check, is it?
The 1/2 power to the 2? Explain that one to me in my head, because I would think 1/2 times 1/2.
No, you would take 1/2 times 2 over 1 to give me a power of 1.
Oh, because
Okay, thank you.
Yeah,
I just
1/2
couldn't
if
see
I
it in my
write it
head.
this way times 2, put the 2 over 1. So that's 2 over 2, which equals the 1 power. So you always, if you have a power, we always take it to the reciprocal power. So if this was 2/3, I would
3/2.
do 3/2
Okay.
there.
Thank
Yeah.
you. I couldn't see it in my head.
Okay. Okay. But yeah, this one is a little more difficult to check. I don't know if you guys want me to check it. Let's go ahead and do it. This would be, I would say this is log of 16 over log of 3 is how I would look at it. Change a base formula, right? And this is 2 log of 2 divided by log of actually do by 2 times the log of 3, right? So if I wanted to get rid of the 2 in the denominator as
But
well,
then would you have a 2 in the left in that one?
so then I'd have a 2 here.
Yeah.
So this would give me the log of 16 equals 2 log of 2 times by 2, which would end up being 4 log of 2.
Oh, so when it's time to.
And then you could make that a power, and then it's log of 16 equals log of 16. That one's a little bit trickier to actually check, okay? But it will work if you do a change of base. What were you asking?
Nothing.
Nothing? Okay. But the most important thing when you're checking is just making sure that you don't take the log of a negative, right? Okay, so as long as your math came out okay, you can check it out fully or just make sure that you don't take the log of a negative number. So that's 11. Jumping to number 16. This one's kind of our second rule, or hint that I gave you guys yesterday. Okay, so we're going to do the same kind of idea with the 2 out front. What can we do with the 2 out front?
Exponent.
Make it a power, right? Okay, but this time the log is on the same side. So we're going to, these are the same. So we're going to combine logs. So I want to write log base 3, and when it's subtract, what will that mean?
Divide.
We're going to divide the parts, right? So then I'm going to have x plus 4 to the second power over 9 equals 2. So the second part of the first hint that I gave you guys yesterday, after you combine logs, if the logs are equivalent on both sides, they go away. If you don't have a log on both sides, what did we do? How?
By change of base with the smaller base.
Change of base with a smaller base? Nope, that's if I had
Different ones.
yeah, different logs.
Oh, you're saying they're the same, you can drop them if they're the same on both
Yeah,
sides.
if I could drop them if they're the same.
Yeah.
But
can
if
not
you get
drop
to this
them-
point,
And
can't drop it.
rewrite it as an exponent.
Rewrite it. Rewrite it in exponential form. Okay, so what's your base?
3,
What's your power?
2,
What's the result?
X plus 4 squared over 9.
Squared over 9. And once you rewrite it, so anytime you get stuck, usually if you just do the opposite, if it's in log notation, write it in exponential. If it's in exponential, write it in log. Okay? So when you get to those, like, I don't know what to do, usually it's a rewrite at that point. The 3 squared is 9, right? And this is all just a normal problem to solve now. Then we times by 9, so we get 81 equals x plus 4 squared. 2 options to go from there. You could expand that out, but do you see a shorter cut? Square root. Good, because it's already a perfect square. So you could square root both sides. So technically we get 2 answers, plus or minus 9 there, right? But the negative 9 probably won't work for us. Okay. So I get, but then I minus the 4, so I'd get 2 answers. Positive 9 minus 4 is 5, and negative 9 minus 4 is negative 13. But when I go back up here, if I put in a 5, will I be okay?
Yes.
If I put in a negative 13, will I be okay? No. Even though you're going to square it, it would be the same as timesing by 2. Right? The original problem was a times by 2. So you can't have a log in the a negative in the log. Okay, so this one won't work. That's your only answer then. It'll work. Okay, with the original problem. So questions on that one? Any clarification? Okay, so let's jump to how to set up number 43. There's two ways you can do this. The way the book tells you, and I think this was my second hint yesterday.
Yeah.
Yeah. So if they have the same base, different bases, what should we do?
At the end, okay.
ln, take the natural log of both sides. So that's how the book solves these, okay? So they'll take the natural log of 3/5 to the x equals the natural log of 7 to the 1 minus x, right? Just ln in front of both sides. What happens with those powers? They get to be multiplied to the front, okay? So I have x times the ln, and why don't we just change 3/5 to 0.6? Let's just change it to a decimal so it's easier to do on a calculator. Okay. Equals 1 minus x times 5, the ln of 7. Can we go from there?
Yeah, we can just distribute the 1 minus x and then change it back, or well, put it in your calculator.
You can't just put it in your calculator yet. 6. Because you have x's on both sides.
So you just divide by x.
No?
No, or you divide by ln.
Do you remember what we do if we have x's on both sides? You have to somehow physically move from one side to the other, right? Like if I had 5x on one side, 4 on the x, you move the 4x
You're
to
gonna
one
factor
side.
it out.
Right, but
Okay,
it's
and then factor it out. So we're gonna have to move the whole term. This is like the coefficient of x, okay? So I have x ln of 0.6 plus x ln of 7 equals ln of 7, and then we can factor out the x. So that would be ln of 0.6 plus ln of 7 equals ln of 7. And then you can divide by that.
Okay, sorry.
Okay?
We ended up doing that whole part.
Yeah. All right. Questions on that one?
Nay.
What's that?
Nay.
Nay. Nay, sir. Okay. 81. Okay, so they did give you the hint of what to do here. We have to be a little creative on number 81, and they didn't expect you to do this creative step on your own. But before I actually do their kind of creative hint, yeah, I would get rid of the fraction by timesing both sides by 2. So by times both sides by 2, those reduce. Leaving me e to the x plus e to the negative x equals 2. Okay? From there, could you combine the e's together by adding the exponents?
Could you do?
No.
Well, they're the same base,
They are the same base.
so could you do like ln and then multiply them together since it's add?
Could you do just x times x equals 1? Because, oh wait, no, the 2's not the same.
Yeah, if this was, so what I'm getting at is sometimes students will try to combine, like add those together and say it's e to the 0, and that's not the case. That's only if you were multiplying the same base